Are we ready?
Born ready.
All right. Number 4. Determine if it's a conditional statement is true. Okay? If it's false, give a counter example. Okay? It says, hey, if I jump off a bridge, if I jump off a bridge, then I land in water. Then I land in water. Okay, first of all, let's make this into a conditional statement using symbols. If. That was easy. I jump into a bridge. What letter sticks out to you with I jump into a bridge? Off? Jump. Oh, if I jump off a bridge. So what letter sticks out to you? J, B, O. I usually think jump. If I'm jumping, okay, J. Does that make sense? So I'm thinking this whole thing I can represent with the letter J. Okay? And that's what in logic we like to do. We're very lazy. Mathematicians are incredibly lazy. You're not arguing with me, so I guess I'm pretty lazy. Okay, so then, what's the symbol for then? Perfect. Okay. I land in water. So some people will use an L, some people will use a W. What do you guys want to use? L. Okay. If I jump, then I land in water. Okay, is this true? Is this always true? If I jump off a bridge, I'll land in water every single time. Why not? So we're saying it's false. I agree with you, but why? We need to give a counterexample. What does counterexample mean? It means a reason. Why would it be false? So give me a reason why it would be false. If I jump off a bridge, I would land in what? Something other than water. The ground. Okay? I could land on the ground. Right? Okay? Alright. Fair enough. Done. I mean, literally, you could say anything. I land in bed. I land on a truck. Right? I land in, I don't know, can't say a pool. You can say a pool with no water. Right? Okay? But in a river of no water. Right? Okay? But anything other than water. And you've given the counterexample. Does that make sense? So all a counterexample means is a counterargument. Okay? That's all it is. Just some other way, something else that happens.
This is the last chance for individual pictures. This is the last chance for individual pictures. If you have not gotten your picture taken, please report to the small gym. Thank you.
All right. Let's try another one. If I add 3 plus 10, then I will get the solution 13. Okay? So how will we write that? If 3 plus 10, right? Then 13, right? It's pretty easy. If I add 3 plus 10, then I get 13. Is that true?
We're simulating.
If I add 3 plus 10, then I will get 13. Is that true? Is it always true? Yeah, pretty much. Always true.
Always is?
Well, I could think of some situations where it's not, but that would be kind of unfair because I have ways of manipulating numbers, right? If I think about a non-10 base system, and we work with a 20 base system, then we'll still have 10 and we'll still have 13, but they won't mean the same thing as your 10 and 13, will they? Right? Because everything's in 20s. 20 and 20 and 20. Right now we do everything in 10s and 10s and 10s, right? In a 20 base system, we would go up to 20 and start over again. Do another 20. So every 20, so in other words, there's only going to be 5 20s in 100. Right? So it's a little bit different. So 10 and 3 will still mean maybe something different. Who knows? I think even in that system, 10 and 3 would still be 13 because it's a 20 base system. Now if I change it to a 12 base system, it can't mean 13 because 3 and 10 are different and they mean 1 again. What? Okay. So yeah. Okay. But anyways, for what we're looking at, we're not looking to, go outside of the normalcy of numbers. So we're like, yes, this is true. Okay? And so if it's true, then we can do a lot of other different things. This is called a con-D, right? Con-D, a conditional statement. Right? Okay? When we look at conditional statements versus converse statement.
According to Roberts, switching the hypothesis and conclusion of a conditional statement. For example, the converse of it is raining, then the grass is wet is if the grass is wet, then it's raining.
Boom! The converse, or the con-V, right, is switching the statement. It's saying, hey, if 13, then 3 plus 10. Right? Is that true? If I get 13, then I did 3 plus 10? That's not always true, is it? Right? Because sometimes I can get 13 by adding something other than 3 and 10, right? So here I could say false, and then I could say, hey, can I get 13 if I add 4 plus 9? Right? So those are some of the things we're looking for, right? But that's a con-V. Con-V means I take the original statement and I reverse it. Okay? I just flip it. Okay? And then we're going to do an inverse statement. Listen to what this Wikipedia says for inverse. Inverse statement.
According to Roberts, negating both the hypothesis and conclusion of a conditional statement.
So the inverse is negating both the hypothesis and the conclusion. So I guess we need to know what the heck they're talking about, hypothesis and conclusion. Well, let's start with this. The start is the hypothesis, and this is the conclusion. Okay? So how can I negate this? How do I negate the conclusion or the hypothesis? Well, I take this and I say, if I do not add 3 plus 10, then I do not get 13. Does that make sense? But if I don't do 3 plus 10, and I do 4 plus 9, can I still get 13? So that one's still kind of false, right? Because 4 plus 9 is 13. Does that make sense? Okay. All right, now we come up, oh, that's called the inverse. Okay. And then we come up to one more, the contrapositive. I call it the contra. So, converse, conditional.
Did you say that was Converse?
Yeah,
Or is there a G?
that's an S.
Yeah, that looks like a G.
Is that better? Okay. So contrapositive is this. Let's see what Wikipedia gives us. Converse or contrapositive statement. Messed up. Contrapositive statement.
According to MathWords, switching the hypothesis and conclusion of a conditional statement and negating both.
Okay, so it takes this conditional statement, it flips it, and then it negates it. So basically, it negates the converse. Okay? So you take this converse, make it not 13, then not 3 plus 10. So if it's not 13, then it's not 3 plus 10. Does that make sense? Well, yeah, because 3 plus 10 is 13, right? So if we don't do 3 plus 10, then it's not 13. I mean, I guess technically, we were going with this 4 plus 9. We could always do 4 plus 9 again, right? But that would be 13. We said if not 13, then it's not 3 plus 10. So anything other than 13, we're going to be adding two different numbers to, right? So this would be true. Okay. True. So look, the conditional statement and the contrapositive are true. But yet these two are false. And that happens sometimes. This is actually more rare. What usually happens is we can make all of these false or all of them true. And in mathematics, we find that they become all true. Let's look at a very simple statement. If they are parallel, then they do not intersect. Or, right, if they intersect, then they are not parallel. Or, if they are perpendicular, then they intersect. Right? In all of those cases, each one of these will end up being true. Take a little quick look at it. If perpendicular, then let's do a fun one. Let's do if they're parallel, then they do not intersect. And the reason why I like to do the parallel and not intersect is it makes it so that there are not two knots on it. Two knots. Never mind. Okay, so converse would mean that I take these and I flip them. That would be not intersect is parallel. Okay, so if they don't intersect, they're parallel. That's true. If they parallel, they don't intersect. That's true. What about this? The inverse. The inverse means I'm going to take whatever I started with, parallel, and not intersect, and then I'm going to make it the opposite, or the negation of it. So not parallel, and in this case, not intersection, which means intersect. So if they're not parallel, they intersect. Well, yeah, that's true, right? So far, it's true, it's true, it's true. So now let's come down to contrapositive. What that does is it takes this, right, the inverse, or no, it takes the converse, and it makes it the negative of it. Does that make sense? So it's taking this converse, right, which is not intersect, then parallel. And it's making the negation of it. So in this case we're saying, oh, if it intersects, then it's not parallel. So in other words, it actually just takes this inverse and flips them. Flips them back. Does that make sense? And this is also true. Okay? So those are two examples of conditional, converse, flipping it, inverse, just making them both opposite knots, right? Or contrapositive, flipping the conditional, and then making it not. Yay! Fun. Oh, what problems were those? Wasn't that 5 and 6 or something?
That was fun. But like, I don't know, you just added more.
Oh, that was a really
Explained it.
big number 5. Ooh, that was a long number 5.